All right. Let's see. We are going to add import puzzle file so we can load what we export. Right, that makes sense too. So let's see. We have to go in our construction mode here. And then we have import around. And then we're going to have to open a file, which is probably going to be hidden on the page. Yeah, so let's add an input that's also hidden. Input type file. ID is import file. So we have that available. And then we have to make this a bit bigger, I think. Let's make that 90. I have to put it up a bit. I have to compile now. Let's see. Where are we? Yeah, so it should be bigger now. So current Y, that should be at the top though. Yeah, it is. So let's put that at 90 and then make the height a percentage of 90. Let's see if that's now bigger. Okay, I always forget to compile here. Yeah, so we have some space over now, some extra space. Let's go to 95 because I need a bit more space. All right, so now we're at 95%. Let's move the X button up a bit. Where's my X? Yeah, I mean, that should be a variable, I guess. Like negative 95, but fine. It's not that much of a problem. Okay. And then we'll do our title here, import puzzle file. Yeah, so let's give that a title. And then we'll see what it how it looks. So yeah, regular rounds, then we have special rounds. I guess it's these 3 lines, bonus stages, which we add, and then the close button, let's add it in between here. And then that would be custom rounds, plural, because we do import 5 levels at the same time, of course. Because yeah, it loads a disk file, right? So do we need to add? I think we need this. Let's see where it ends up though before we change it. Yeah, that needs a bit of space. Don't know if that's going to be enough. That's too much. Okay, and then we will add a load file button, load PZL file, I guess, which is then the button. We might have to move up the height a bit. I mean, we could reorganize it though to make it into 2 columns, but yeah, because we are using like only the height and not really the width. But let's see how it looks if we add in the same font size the load PZL file button or clickable thing, I guess. So this is this one. Okay, and then we'll indent it a bit, just like the other ones. So we don't have to do this. We don't have to do a dynamic piece of text. Just or select, I guess, because that should open up the file selector from the browser. Current X, current Y. I think we have to indent or like add some stuff here too. That's fine. Current Y. So we have to indent though. Yeah, I think this is this. Oh no, that's why. Current X is start X. Right, so we have to reset that, I guess. Let's see how that goes. That does not work. What did I? Oh yeah, this stuff might not work. And then we need to do this. Okay. Okay, why are you not working here? Let's get the errors in play. I did change my browser scaling, so it might not be super visible. I is not defined. Where am I using I? Okay, this, we don't need this. I might add a bit, but if I change the scaling of the browser, the rendering of the canvas isn't perfect, so that's why I did turn it back a bit. Okay, so we have to increase our Y. That's fine. And then we have to, yeah, we chose a smaller font size. Okay, so we are missing out on, well, we don't have enough height, right? Because that would be the Y coordinate, like a nice spacing here. So we need a bit more percentage on our black background. So let's go to 8 and see what that gives. All right. Yeah, that seems better. I'm going to add a little bit more before custom rounds. I want a little bit more space, just as there is between these guys here. Okay, so a bit more space here now. That's good. And then we have our select puzzle file, which is clickable. Okay, which does nothing at the moment. So I think I can just address the hidden file input and just click it, I guess. So that's in this event here. So we're getting import file.click. Let's see what that does. I do have to check what happens when you do 2 puzzle files at one after the other though. Because I want to do an onChange event. I guess I have to do an onChange event on the... Yeah, so that does work. Let's go to... Well, wait, let's export one first. So I'm going to cancel and I'm going to load in, I'm going to import like 55 on on these guys here, 56, 57, 58, and 59. So we have something different, right? So now we have 5 different levels that we immediately recognize, and I'm going to export that. And I'm going to name that 58, no, 55 was it? To 59. Nope, not there. Come on. 55 to 59. Let's put that in the downloads folder, and then let's see if we can pick that up. Yeah, I think I have to add a filter. I think I can do that, right? Like add a filter on the selection thing, on the file importer. So let's input type file. Okay, I think, okay, let me adjust the browser scaling though. That should be this one. Okay, so now we're in 2x mode and we can see a bit better. I have to put this back on 100%, but now it's more visible on the stream. And it still seems to look okay. Right. Okay, so yeah, input type file. Can I specify the filter? Accept. Okay, yeah, that's just top PZL, I guess. Okay. So now if we import select PZL file, we get our reasons all. I mean, I can go to downloads. Yeah, that's just the PZL files. And I think we have to look at the events though. What is it capture here? Well, no, that is for photos and stuff. Limiting accepted file types is what we did. Cancellations. Okay, so we have a change event and a cancel event. So I only need the change event, I guess, right? Yeah, so let us install a change handler for, I mean, we have to do that in initialization, right? Yeah. Okay, so we're going to add that to our functions here. Where are we? Yeah, this is the encoding function, decoding function, fetching function. Okay, this is, okay, the position. I'm going to, yeah, this is for the import. This is part of the import stuff. So I forgot the name. Import file is the name of the thing. And then add event listener, is that the thing? Yeah. Add event listener for change. And then we'll add a little function here that logs our file, which is then dot, well, length has to be 1. Okay, sure. And then files 0. No, it's files.length bigger than 0. Then we take the first. Okay, so we call this, so that should be good. Right, so we select the file, select this one. Right, we have the file name, we have the size as well, which is irrelevant, I guess. I mean, if you do a very big file, you're just screwing over your own browser, right? Now we have a last modified date or timestamp. Now I want to read this file though. How do I read this file? File reader. Let's see. Is this asynchronously read the contents of files stored on the user computer? Okay. We just have to put that in an array, right? You just read the thing in an array, and that should be good. Because we'll just check the first byte and see whether it's FE, I think it was. And if that's the case, that means we have a higher chance of getting a correct PZL file. I mean, I don't know what amount of error handling I'm going to put in there. But yeah, everything is running in the user's browser, so they're screwing over their own browser if they're loading invalid files, of course. I mean, the files can come from everywhere, I guess. Like, there might be malicious data in there. But yeah, I think, oh, we have a read as array buffer, that's fine. Give me an example. An example for me. Because yeah, we have to, oh, okay. So accessing selected files, okay. File API, access a file list containing file objects. Right, that would be the 0th file here, I guess. The select multiple files, which we do not do. Can we actually select multiple files here? No, we cannot. So that's good. There's only going to be one file. Okay, so we access the file. Accessing selected files on a change event. Okay, which is what we want, sure. Now you can work with the file list, okay. I do not need the file list data. Is this a file object? Yeah, it is a file object, that's good. What is this? Oh, this is my edit mode. Okay. Name, size, and type, fine. Sure, that's what we already did. Selecting files using drag and drop. No, I just want to read the thing. Object URLs. I need file reader, I guess. I'll search for file reader. Okay, is that everything? Showing thumb. Okay, this is going to pre-process the uploaded file, right? So we are in the change handler, I guess. New file reader on load E. Okay, how do we specify what that belongs to though? Oh, read as data URL. Okay. I guess we are going to call the hide import pop-up once we're done. That also makes sense. So let us add the reader, and then reader.onload. I mean, why would you not do add event listener here though? And then let's log that out. Right, and then we say reader read as, I want to say array buffer, and then we have a blob. I guess file is a descendant of blob though, so that should be fine. And then take this. So no, not that. This. And let's see what that does. I hope this gives me the data as an array list. Import file. That's slow for some reason, I don't know why. So okay, load is then the event I guess we are getting back, and then we have to, how do we get the data? eTarget result. Do we have that? Can we see that here? Target. Ready state is 2. Result is an array buffer of 358 bytes. I think that's what we want here. What was it? 359? Yeah, 358 bytes. Yep. So now we have an array buffer. Can we convert that to a type buffer? How to get an array from an array buffer? Okay, just do a new, okay. Okay. Boom. So we have FE and our couple of zeros, and then we go on to lotus position, exit position, and then, oh, that's weird. Let's look at the file in the hex dump. Right, no, this is going to be lotus position and the exit position because I'm not looking at level 0 here. I shouldn't, because we're loading like level 55 and stuff, so it's different. So if we go look at the contents of this file, then we see that indeed we get FE, a couple zeros, and then 86, which is of course decimal here. Which is 134, yeah, okay, so we're getting the data as bytes, perfect. And now all we have to do is strip out the first, how many, so we have to check for FE, and then 1, 2, 3, 4, 5, 6. 6 we have to drop, and then we start with 3 power-ups and the rest. Okay, so we have to drop 1, 2, 3, 4, 5, 6. 4, 5, 6 zeros, and then FE. So 7 we have to drop at least. Right, now we have to do some error handling. If it's not correct, then we have to show some sort of message, right? We have to make an error message thing. I guess I can just do a pop-up that isn't super, like it doesn't have to be graphical, right? I can just do an error message, an alert. That should suffice. So if data 0 not equals FE, then we have an error. So yeah, this does not appear to be an Eggerland Mystery puzzle file. And then we have to return from this stuff, though, which we can just do, return from the event. And we're going to try that by copying 55 to bad puzzle. And then we're going to read that file and change it. Introduce this error manually. In downloads, we have the bad one. And we are going to make that DD, for example. And now that's an invalid puzzle file, right? So that's what I'm trying to trigger here. And that should work too. Like it should give us an error now if we are trying to import a bad puzzle file. Yeah, this does not appear to be an Eggerland. And then, of course, the correct one should not give that message, which it does not. It dumps me the data. Okay. Now I have to see what I do for parsing the level, because I think I only have code that does one round at a time. So yeah, the code Eggerland 1 round data expects my data to be base 64. I guess I can do that, though. That's fine. Unless I can just do this. I don't really have to do that because I already have this decoded like uint8 array, right? So I don't need to do that. Yeah, I can just give 1, 2, 3, 4, 5 and then pass the thing to new Eggerland 1 round. Then just pass that and see what happens with that. Okay, that's the fetch function. Right, and I just have to do this. I guess I can abstract that into a different function, though. So the fetching is indeed the decoding then, and which I can put into the decode function as well, though. Yeah, I think I have to. I'm going to have to abstract that away, like make it more universal, right? Let's see, because I do need to execute all this stuff. Well, like we do need to set the power up data and the construction board data, but we don't need to necessarily call the update functions. I guess we can, though. It wouldn't hurt anything, right? Because that's just updating the textures and stuff, but that's fine. Like that happens 5 times, then probably faster than you can see, so that shouldn't be a huge problem. Yeah, so I guess we can do load Eggerland 1 level, actually round, and then round gets passed, and then we say this load Eggerland 1 round with this as the result. So now we have this function separately, right? I mean, it does suck that we have fetch and load now. And also I'm gonna make this round. So how does this look? Because this is just, okay. Actually, I can like replace it with this. But that is fine, I guess, because we have to do the logic of making it 0 based. Yeah, that's fine. So we have our load function then, which we now can use, right? All we have to do is give it a round, and that we get from this guy here. Okay, so we have to instantiate an Eggerland 1 round from our function. Now, the difficult part is, and I've already done this though, so that's not a big deal, is see where our rounds end, because we have 5 in the file here, so we have to like read one and see where we end up, right? Because they're sequentially, like they're all next to each other. But we have to see, like we have to read one and see where we end up. I don't know if I can do that. I mean, it's all like the amount of bytes are in there. Like I do know how long each level is, but I don't know if we can extract that. Do I have this here? So data length we have. Maybe we have to put that in a variable we can access though. Yeah, that might be necessary. So let's see, where is our function we were working on? Yeah, here, this guy. So I have to remove the first 7 bytes though, like what is it, array slice or something? A shallow copy of a portion of an array, okay. Into a new array object selected from start to end. Can I do this with a typed array though? Yes, apparently I can. Copy of a portion of an array into a new typed array from start to end. And that's assumingly, yeah, that's just the first position. So just slice, I guess. So if I say data slice 7, then I assume we get the first 7 bytes stripped. We should start with 3 zeros and the data, if I am not mistaken. Yeah, 3 zeros and then the data. Perfect. And now, like, I can't pass that to the decode function though. I need it to be correct in size. So I guess we have to do the split in the current function here, in the event handler. Yeah, so this is the thing we have to do, right? I'm going to do that separately. I'm just going to read it, right? It's like it is the 5th byte, or it's byte 5, or the 6th, I guess. That contains our data length. So let's just parse that. So we have, let's call this all data, and then round data is, well, no, we don't have to call this all data. If we call the other one around data, let's call it rounds data. And then we look up for 5 times, I guess we do this, for so we're doing this 5 times. I guess we'll keep track of the start. Let start index equals 0. And we're just going to increment that, right? So what we have to do is rounds data start index plus 6, I think, is going to be the data length. And what did we do? And OX7F, right? And then that should be the section that we have to slice out of it, right? So our round data would be rounds data dot slice start index, and is it length or an index? Start and end. Okay, so it's the zero-based index at which to end, which is start index plus data length. And I think that would contain our round data for each round. And then what we have to do is we have to set start index to 7 for the header plus data length, and then we have the next one, right? So I guess we can log I2. So we should have 5 levels now with their individual data dumped. Let's see if that works. No, we have 4 of them. The 5th doesn't work. So we have, okay, and they're wrong because they should all start pretty much with 0, 0, 0. Oh, and they're only 9 bytes long. That's also incorrect. So yeah, we're doing something wrong for sure. So index 5 is 189, right? So we have 3 power-ups. We have the low-loss position, exit position, and the length. So data length is 189. Let's look at that variable here. In decimal, 189 is hex BD. The top bit is set, which we are going to strip away. And that becomes 61 or, yeah, 61 bytes. So instead of like 9, we should have 69. No, 61. Why is that not the case? So let's log. Let's log the data length we are parsing. Why are we not logging this? Okay, yeah, so data length is 9. I do want to see what rounds data start index plus 6 is. Okay. Zero, 1, 2, 3, 4, 5, 6. Okay, that is this 9. Wait, so starting this, oh wait, am I confusing? Well, it is 5 though, right? It's index 5, so we're adding 5 to 0, which becomes 5. Okay, so we have to go 1, 0, 1, 2, 3, 4, 5. Okay, we have to do 5. Yeah, not 6, of course. Okay, 61, 189, that looks better. So we have 3 zeros. Okay, we have 2 zeros, but that can contain a power-up though. I don't remember. Do we still have them? No, we don't. Of course, we refreshed quite a bit. So we're still off, but 189 becomes 61. 61 was correct, right? Yeah, so that's correct. And then we do start. I don't know, the second one has power-ups though. So we have our 3 zeros for the start level, which do not have power-ups. And then where's the next one? Here is one. 00117. I mean, this looks like about 61 bytes. So we have what, 1632, and that's twice. Yeah, it looks like this one here. So we should be at position 4A, and we are not. Oh, did I also say 6 here? 7 plus data length. That should be 6 then, right? So we have 1, 2, 3 for the power-ups, exits, or Lolo exit length, which is 6, and then the length. I think it's 6, right? Did I change it already? Yeah, I think it's 6. For the length. And let's see. Yes. So we have 3 power-ups, all 0, 0, 0. Yeah. And then the last one, perhaps not, unless that one does have a power-up. It might, though. Because it could be like this could have a potential power-up. It was 59, right? So let's load 59 here. Yeah, it has a power-up. So that's correct. Probably. Well, where is Lolo here? That's set at 0, 4, right? 0, 1, 2, 3, 4. Yeah, that's this 4 here. So x0, y4 becomes 4. Yes. So we have sliced them correctly. And now all we have to do is pass that round data in our round constructor, just like we do here. No, this one over here. Where is it? This one here. And then we have a round instance. Where are we here? And then we do round data, and the index is going to be I, that's the round number. And now we have to load it, I guess. Load Eggerland round. We do have to set our current level, so we're doing the same thing in our constructor here, though. Yeah, so we're doing this, right? Yeah. So we have to loop 5 times again. Are we looping here already? Yes, we are. No, we don't have to. No. We are already looping. We just have to load it in. Yeah, we just have to set the current round number, and the load function immediately puts it in that correct thing. I think that should be it, though. So select this one. And did we change? No, we did not. Why? Oh, I'm still having stuff here printed, so I'm not up to date. So import, we have, yeah, we have the standard 5 levels. We're importing this one here. Okay, it changed, but we have an error. That's fine. Yeah, there's something off with the data, though. And it all seemed to have loaded into the 4th level, or it didn't save. That's weird. Oh, do we need to do an update? So the load function does all the updating for this current round number. That should be fine. But then do we have to call an update or something? Apparently not. We just have to hide the pop-up, which we can do too. Which is after the 5th, like after the loop, which is here. Okay, but why are we not? Do we have to do +1? Wait, the current round number is 1 based, I think, or is it? I should change that. So it's all consistent, because I did a couple 1 based and a couple 0 based, and that's not really optimal. Yeah, so -1, so it is 1 based. Okay. That's probably why this one errors here. Okay, so let's see if that changes something. So we're in the first 5 levels. We load our good puzzle file. I'm gonna, okay, that's still not fixed. I'm gonna remove the bad one though, so it doesn't appear. Yeah, this doesn't look good. Or yeah, no, that's you can't solve that. So there's definitely something wrong there. But if I go back, oh no, now it did save it. That's good at least. It saved it all in the first one though. Yeah, this should put this in the correct. It should put this in the correct array index. Like, why would it not? So what is this? Is this 55 or 59? Let's look. 55. Yeah, it's not 55, right? It's 59. Or maybe it's crashing in between somewhere. Is it a mix of stuff? Or is it 55? Like, I think it's this one, but it's... First, let's see what this is. Animated sprite. Okay, so yeah, it's loading the wrong values, right? Because it's trying to render sprites that it doesn't have. It's weird though, like, I thought my slicing was correct though. So round data should be correct. Oh, it already breaks after the first one. So we're doing something incorrectly. Do I pass just no, I pass everything, right? Including the power-ups. Yeah, I mean, this looks correct to me though. Like length 61 was what we figured out, right? 61. Wait, let me try loading that file in actually in Eggerland, because I'm assuming now that the export is correct, right? Yeah, I mean, you never know. Okay, I need a different machine, one with a disk drive. Okay, we're loading the disk drive. We're loading the Eggerland ROM. Let's edit or add the puzzle file to the disk file. So it's this one, 55-59. Okay, we go to construction mode. We select the filer and we load 55. Right, why can't I? Okay, it's the same thing again where I can't load my or I can't type my text here. Oh, it only it doesn't load numbers. I didn't know that, so I have to rename it. Okay. Can I rename it here? Yes. FF to F9, FFFN. Okay. No such file. Okay, it's not aware of the files, I guess. Okay, now it's just gone. What the fuck? Oh, of course, yeah. I'm used to it's not touching the extension, as is the case in modern operating systems, of course. FFFN should now appear. Okay, and then we load FFFN. Okay. Yeah, so the file seems to be correct. The exported file, which is what we tried in the when we made the exporter, right? So that looks correct. So yeah, we are parsing it incorrectly. That's for sure. It should look like this, and that's weird though. It should look like this, and it looks like this. Like we have some stuff. Is this? Well, no, it's even wrong here. Like, what the fuck is going on here? That's super weird. Like some stuff is correct and the other one is completely wrong. If this is a horizontal one, then it already fails here. If it's a vertical one, it fails here. Let us look at I want to look at the hex dump or the dump of level 55. How I'm gonna do that? I mean, I have the rounds here, right? So I can look at this. If I go to 55 and I copy this, I have a base 64 encoded version of this level. And I can then wait. If no, I don't have to do that. I can use the fetch function for that. If I just load this and yeah, if I print this out here, then it's then I can dump the data here as well, right? So if I do 58 here, no, 55. Why are you not dumping this? Oh, is it? No, it's bytes, right? Yeah. Why are you not okay, now we did it. Okay, I needed to force refresh, I guess. Okay, so this is our data, and now wait, let me clear that out. So we have a blank slate here. I'm importing level 55, so this is what is correct, right? It's 67 bytes. Oh, are we missing a couple at the end there? 67 bytes, because we only have 61, right? Which is that's suspicious. So that's not good. And now if we import our file here, we can see what the difference is, right? So, I mean, it doesn't look that much different other than these 6 bytes. That's weird. So we're ending with 24, and we are ending at 60 with 24 too, but that can repeat, of course. Yeah, so it doesn't do these last 7 bytes or 6 bytes. But could that mess things up though? As in, would it just not have data for the last 6 cells, the last 6 things? Because for the rest it looks identical, right? So we have power-ups, low exit position, and then the length, and then we just start adding stuff, right? So it doesn't diverge, I think, in data-wise, like 964, 980. 964, 980. Yeah, that's the same. So no 0, 10, 240. Yeah, that looks identical. Why are we dropping the last 6 bytes? So it's these 6, right? Well, no, because the start index is correct. The data length is, however, only okay, the round data starts at start index, but it needs, of course, the header as well. Okay, that does make sense. Right. So we have 3 for the power-ups. Low is 4, exit is 5, and then the length itself. Right. That does make sense. So let's see if that makes a difference. Yeah, it seems to work now. It shows the wrong one, but yes, it skipped to 5. So I need to set this current round number to 1, and I need to, how do I update this? No, I have a function for that. The same one that happens when you click on the round number. Oh, what is the function name now? Can I see my function names here? It's not fetch, right? It's like select current round number. That's the one, right? Yeah. Yeah, so we go to round 1 instead of 5 and then leaving it on 1 here. Okay. So we import our puzzle file. Right, that's round 1, 2, 3. These all look perfect, right? So now we have code that loads puzzle files. We just have to be careful, I think. I mean, do we though? Like, I'm thinking about malicious data, right? What could go wrong is not much, I think. So the data length is indeed that's something that's passed. That's always dangerous, right? If you just blindly accept the length or a length of a bit of data, because we are passing that here. But I think that sliced is smart enough to do bounds checking. So it shouldn't be a big problem, right? If it like allocates 10 gigabytes or whatever, that shouldn't happen. Right, so let's see. Now what I can do is load a puzzle file that I did not create. Let's see if that works. There are some repositories of people that made custom levels, but I don't know if I can find them. Yeah, so I don't know if this is still going to exist. Potential security risk. Yeah, that is fine though. That's not going to be a security risk, I'm pretty sure. Let's unzip it with the command line. Oh, that's one disk file. Oh yeah, okay, it's a disk file, so that means that they put everything immediately on a disk file. Okay, fine. Let us attach that disk. Well, no, I can open it in the manipulator, perhaps. Right, no, I need to assign it to the drive first. I can open this and fetch that from my downloads folder. Right, so that's now assigned, and then I can open the disk manipulator. Yeah, okay, so we have all these puzzles, and can I make a new directory here? We have custom puzzles. I can select everything. Yes, I can. And I can copy those. Okay. I'm going to take a peek in the hex editor to see what they look like, but they should be fine. I mean, they should have the pointers at the start of the head, like the header of the file. But those are irrelevant, right? What's going on here? Okay, Ubuntu. Is my hex editor open? Yes. So let's open a random one. In the custom puzzles here. That's being weird. Like, what is going on here? Maybe it was malicious. Okay, so it starts with FE. It has 3 pointers, that's fine. And then we have power-ups. AA, not sure what that one is, but let's see. If we can load these guys in my online editor here. Downloads custom puzzles. Let's take the first one. Okay, this one is Ubuntu is doing something weird here. Don't know why it's so 801. I think that is correct though. I think this guy has the maps. Yeah. So these are the maps of these levels, and indeed the first level is this one here. So we're gonna have to do like load a bit more down the road to see a bit more complex ones. But yeah, these are like completely independently made levels, and they load just fine, right? Let's see. I'll get one from down below here. I don't know why my file selector is so slow. 41 it said, so let's see. So A41 is this row. Yeah, that's this level here. Yeah, load over there. Yeah, that seems correct. Oh, can you even see that? So the respawn position you probably can't see in this map or in this person's map, which you cannot. Indeed, it's right here, right? The respawn position, but of course you see that in the editor, right? Yeah, that's pretty cool. All right, looks like a complex level. Okay, so that seems to work. I don't think we have to do anything else for importing, right? Oh yeah, can we do, well, yeah, we can do multiple at the same, one after the other, right? That just works. Right, that's one of my test levels. Yep. That's the plain first 5 levels. Okay, so we've added that. Yes, we added that. That's also changed, of course. And then, yeah, I've made some name changes. The handler, the size of the pop-up. That's simply the name change. Then we add the selection text. We add the function to handle the selected files, and that's the name change. Okay, and the separation of the function. Okay, implement importing of custom PZL files is done. All right. Next thing I want to do is either do the file size table to compare the algorithm sizes for horizontal and vertical algorithm, which one is chosen, like which one is chosen for which level, or I want to do the dumps of all the 115 levels. I think I'm going to do the C++ one first, where we dump the table. Yeah, that sounds like fun. Let me see. I don't think we need you. We need a new VS Code because this is in the Eggerland levels project. Okay, so now we just have to re-implement the encoding of levels. We have decoding already implemented here. Now, question is, I'm going to have to decode and then re-encode, right? So we are able to parse. If you look at the main function here, instead of this, which is a custom round, we already have this. And yeah, so we're loading the ROM and we are dumping the JSON out. We don't have to do that. Well, I'm going to leave that, but I'm going to leave out the dumping of the JSON base64 encoded rounds. I'm going to go to this one here. Right, so this just dumps all the levels to the console here. All right, so this is with a little bit color coding all of the data. So I do get round, and then I need to do I need a function that just implements the encoding of just the blocks. I don't even need to create it so it has the power-ups and stuff included. You can just add like 6 or 7, right? Or 6 bytes to add the header data. If you want to do full counts, I mean. So yeah, I'm going to add an encode function. And the encode function is going to take the algorithm, and then yeah, we'll just implement that. So not in ROM but in round, we have a parse function, and let's add an encode function. And I need to know the algorithm. Where is the algorithm defined? Is the entity or in ROM? No, it should be in round though. Where is algorithm defined? Okay, I was looking over it. I guess it has to be above that. Let's see. Okay, so we have the parse function and we have the encode function. We switch on the algorithm. Start with horizontal, that's the easy one. Now, what do we want to return from this? I guess we can do the array. We don't really need it though. But it would make sense though. Like, how do we get? We have a vector of uint ATs, I guess, that we process. Yeah. So that's what we're going to return from this function. And that's going to be our data, which we will then return. For the horizontal array. So let me look at the JavaScript code, which we already implemented there, right? So we have an encode function. That's for the file. That's not necessarily. I guess, well, the power-ups also have to be encoded, right? I guess we can just add it. It's fine. Not like we're gonna need it, but like for completion's sake. So we have the blocks and the power-up data. We have this accessible, I assume. So we have 3 power-ups and we have the counts. I did not put these in arrays either, which I can do though. Like I have to change that. Yeah, that seems better. Let's put that in an array of power-up 3. And let's call that power-ups. And then we can fill this, I guess. Do we have a fill here? Oh no, I'm thinking about JavaScript. But that's fine. Is it going to complain about well, no. I guess that's it, right? Yeah, that's what I was thinking. It doesn't have an initializer. Can I just do this? Right, the 3 power-up functions. Need to access that new array. Power up and then romhacking. Okay, that should compile. What are you complaining about? No, semicolon, I guess. And then these guys were incorrect as well. Power ups 0. 1 and 2. Okay, that's the same thing. I guess we can loop this though. Or we can just, yeah, no, that's fine. Right, and we have to put the hard framer count into an array as well. Okay, that still works. Yes, it does. Okay, and then this becomes an array as well. Power up hard framer counts. Okay, and we have an error here. Yes. Okay. Who is complaining? Oh, did I copy something? Yeah. What was this? Unit 80. Okay. Still works. Yes. Okay, now we have that in arrays. That's a bit better. Right, because we were looping our arrays, our power-ups here too, right? So that makes more sense. Let's just convert that. What is power up again? That is an enum class. Okay, so we just need to convert that to the underlying, right? Did we do that already? Yeah. Okay, so we have the power up as a value. .id, that's fine. And then hard framer count. That would be, that doesn't have to be converted, so that's power up hard framer counts index I. Right, and then that's just added to it. Okay. Then, so that's the power-ups. Fetch position, yeah, that's the conversion. I guess we have to do that as well. Let's start with, oh, right, we're only calling this. So what does this lambda do? We're finding an index, flooring it, yeah, to get the x and the y position, right. So we need some sort of find index function. That's just slot find, right? I think, or vector find in the blocks, and we do have the blocks, of course. Raw data. Yeah, that's just an array. So we have stud array find. That's just stud find, maybe with a predicate, or is stud find enough? Those are the implementations. Okay, does it give me an explanation here? Find searches for an element equal to value, so operator equals, that's enough, right? Because we are just, what do we have in the array again? Unit 8Ds, so that's fine. Yeah, okay. So we can just do stud find. I'm not going to check for the end because it's always going to be in there. Like there's always going to be Lolo and an exit in there, so that's fine. Should we do a lambda for this too? I guess, right? So don't think we have to make that const. Do we need something? Yes, we need something. We need here the cell indexes, which is an array or an unordered set, I guess. Do we have, so these are the cell indexes, right? Do we have these? Well, they are uint 8Ds, right? So I guess they're block indexes, but that's fine. Okay, you don't know about an ordered set. Now we have to find, yeah, we have to do a predicate because we have to do we have to check the set though. But we have to do whether it's the set includes the stuff. Right, so we have to do find if, and that's also begin end, I guess. Yeah, with is even, which is a little lambda that takes the parameter. Okay. What does that? What's that? Okay, it returns an iterator, and that should not be end. Okay. Let's see what we can do with that iterator. And that would be blocks. Why is not available in my autocomplete here? That's just because I'm in a lambda, I think. Begin and then we have our little function, and we get an uint8d value in there, and then we have to check. We have to also access cell indexes, so we have to make that available. And then we have to just see whether value is in cell indexes, right? And we have to return true here, I guess, if we want it. Is even returns a Boolean value. So return cell indexes contains value. I think that's fetch position, at least the first line here, that's the index, right? Now I don't know what we can do with that. I don't think we can print that, at least as an iterator, right? So we can't really dump that, I think. Okay, what are we complaining about? Fetch position set but not used, sure. And place back. Okay, so let's do this. We are emplacing fetch position of an array of cell Lolo. Do we have these defined? Yes, we did though. Entity colon. Oh, so we have to do entities, I guess. Why are we not storing entities in this though? I mean, I guess we have to do underlying then. That's fine. So this is Lolo. We're passing this. I guess that would be that. And then we do the same thing for exits and oops. Exit with Emerald Framer. Okay. Fetch position. Yeah, that returns the wrong thing though. So let's return 0 here because we don't have it yet, right? We don't have the correct value yet. We have to calculate x and y. Okay, so index. I guess we can do pointer index. Well, what is this iterator again? Because I do need the index of the thing. I don't know if that's doable with this function. To find the index, we can use just that finds by subtracting the pointer to the beginning of the array. Okay. Index equals this. Well, let's see if that, and then if iterator equals mblocks end, then we would just return 0. That's fine. And then now we can do auto index equals mblocks iterator minus mblocks begin. Right, so this should give us the index, right? Okay, let's call this function, because we're not calling it yet, right? And then we have const auto encoded horizontal equals round.encode algorithm. Do we have to specify the entire thing? I guess we do. Horizontal. Okay, so that should at least call that dump function. First time. Okay, so that worked. Right, and that seemed to do the trick as well. 063. 63, that would be 0 and 85, I think. Although, what is 63? Yeah, no, that's incorrect. But, oh no, it's the index. It's the index. And 0 makes sense because that's the first position here, right? Lolo is the first position, and this could be indeed the 63rd entry here, but we just have to convert it to X and Y, right? So we have to do this. Yeah, we have to divide by 11 to see how what X and Y is. So auto Y, well, let's give that an explicit type equals stud floor of index over that's board width. I have 2, I think. That should be a const somewhere. Blocks in round. Where is this defined? Okay, blocks per row. Per row, yes. And then X equals index minus Y times blocks per row again, right? And then we're returning X shifted 4 plus Y. I mean, I'm not printing it anymore, but let's just do that. All right. Who's complaining? Index over. Okay, we're doing some conversion here, I guess. So that's the size T. I guess we have to Oh, is this converting to a, okay. So I'm going to just cast that, right? And then I can use auto. And what are you complaining about? Converting from long to uint AT. Okay, so index is a long, right? And then we're going to do the same thing, right? Right. Okay, so we have our x and y. Let's see what that gives us. Doesn't crash at least. I think these are correct. So 133. Okay, let's dump that in x. That would be a bit better. And now we have the 85 at the top, I hope. Yes, yes. So 0, 0, and 85 we have encoded correctly. So we have our power-ups, we have our Lola and exit position. Now we have to do the horizontal algorithm, which isn't super complex. So basically, I'm just going to copy it. I mean, just convert it from JavaScript to C++ here. So that would be a uint AT. Well, that's going to be, so the previous block, we have to use something that we don't have, right? Or are we using entities? I don't think so. No, because we're using M blocks here. So that's definitely already going to be M blocks. And that's going to be size, I guess. Which is 121. That's correct. That's going to be a size T, and that's also going to be a size T. Yeah, this we're going to have to think about. Let current block equals, that's going to be uint AT or an auto, because that's implied from the blocks. Horizontal data. Right, we're just going to add it to data though, because we are creating the entire thing with one of the two algorithms. All right, so now we just have to make sure that we don't, like we have a marker here, a magic thing for previous block. All right, we can't use 0, I think, because that's the wall. FF perhaps. Yeah, if I do an invalid for FF. Let's see if that works. We do need to encode this as base64 though. That would be the best, I think. That would give us a way of comparing the decoded and encoded values, right? Okay, so we are going to do this in our main. Let's dump the round first, and then we'll use the base64 output. Encoded horse, so that becomes a vector of uint ATs. That's good. So that's just this. That returns, I think, right? Where is this? Yeah, that just returns the thing as a string, I assume. So to encoded or b64 equals this. Let's just dump that. And then we can compare if, of course, the level is using the horizontal algorithm. Okay, we have our horizontally encoded levels. So the first two were vertical, right? Because it makes more sense to do this vertically. So I don't know which one is the first. I mean, I should dump that as well. Okay, there's a couple enters here that we have to add to make sure to separate it a bit more. I don't remember. This one might be horizontal, so let's look at round 5, no, round 4. Right, round 4 is this. So let's look at our dumped levels. Round 4 is this. ULKPD. I don't know, it is different. Wait, why is it different? Is it perhaps the vertical one? I mean, it could be the vertical one too, of course. I would have assumed that they went horizontal like this, but maybe they went vertical. Okay, round 5. IYE. Okay, that is different though. Also different. 6. Okay, Q. No, these are all different. I might be making a mistake here. I guess there's only one way to find out, and that is to parse it again, right? So yeah, I'm just giving this data. I might as well though, like, yeah, let's just try that. Oh, I did not add the length, the data length. That's an important one. So yeah, horizontal position. So we have to add the data length. Right, this is what we're doing here, right? Yeah. Right. And this one I'm going to have to overwrite because so we have to push it first. So we're encoding the exit position, and then we are inserting dummy length. Right, which we then override with the actual data length here. And we're just gonna count, right? No, I'm going to do uint AT because it's always going to be smaller than 255. So we start at 0, and then we are going to, every time we emplace back a thing, we will increment the data length. Well, yeah. I mean, we could have looked at the data length minus the header size, which might be better. Yeah, let's do that. So what are we? 3. So 3, 4, 5 is the 6th position. So index 5. Data 5 equals the data.length size in C++ minus 3, 4, 5 positions, right? Or is the 6th also included? I mean, no, let's see. Minus 6. What do we do here? Yeah, we only have to add 128 when we do the vertical algorithm. Oh, we have to do that here then, I guess. And then we do the same, but plus 128. right? Yeah, the data length does not include the data length itself, so I think it's 6. Okay, let's see if that works better. What are you complaining about? That's too big, I guess. Yeah, that's fine. That's always going to be smaller than 255 anyway. Let's see. Round 4. Is round 4 the same? ULKIDW8PCEA, yeah, and we end with APDW equals. Yes, so the horizontal algorithm works. The next one, IYE, and with CCGP, yeah, that's the same thing. So that one works. Okay, good. Now let's look at the vertical algorithm, which is a bit more complex, but not that much. Let's copy this stuff. I mean, it's not that hard. So we're starting with the same previous block and current count. We have the same, oh, right, now we're doing X and Y. So let's just change that to columns per row, blocks per column. No, that's per row. And this is per column. Right? And as this becomes blocks. This is an auto because we can induce it from m blocks, and then the width is blocks per row, and then this becomes OXFF as a check, and then we say data and place back again for this one, and that is it. Now let's do the same thing for dumping it. So we have our vertical encoded data now. As well. So now we can look at the first two levels. These are vertical levels. Right, so it should be this one. You can already see that the size difference, right? If you encode this level horizontally, it is way longer than if you encode it horizontally. So that's what they did in the 80s, right? Couple A's, IWLI, and ending with EEAQA. Yeah, that works too. And then the next one is ending with GGCDWW, an equal sign, and start, yeah, GUI. Yes. Okay. So now that we have encoding algorithms for both, encoding code for both algorithms, we can compare the lengths, right? Which was the point of this. So what I need to track now is the lengths. Do I store this in JSON? I guess I would, right? Well, no, I'm gonna hard code that in HTML. That would be the. Although, so let's see what this output does. That's just a rounds as an array, right? I have to change that. That should be just an array, not an array of objects. So we don't have to dump that one. but we are going to rename that to rounds as JSON. Okay, do not let me do it myself then. Okay. And now we need to keep track in another JSON file or JSON object the lengths and then the round numbers, right? And the chosen one. Yeah, we have to determine which is the chosen one. That means though that I have to store which algorithm is being used. So I have to keep track of that better as well. Do we have that? Yes, we do. Where do we save this? Right, so we do save that. Okay, we do have that information. We just have to have an accessor for it. Okay, which we have now. If we implement it, okay. So we have access to the algorithm. If it wants to compile, which it doesn't, okay, that's fine. Why are you complaining? Okay, I said typo. Wait, what? Rhythm. That's correct. Oh, yeah, we are in round though. What's wrong here? We are in round. We're returning an algorithm. Oh, that's in round, of course. Okay, so we have access to the algorithm. Now we need to store this data, right? So rounds as sizes as JSON. Let's say we have the round number. That's I. Is it +1 or no? We start at 1. That's fine. Then we have the horse size, which is encoded. Well, no, encoded horror.size. Same for the vertical one. And then algorithm equals round dot algorithm equals that's a bit long. I need to add a using, I guess, horizontal or vertical, right? And then, yeah, no, this should be an object though. And then we say this, what is it, pushback O. And then let's dump this out too. Round sizes, nope, round sizes as JSON dump. Let's see what this gives. No, this needs to have a semicolon. Okay, let's put that in a file. Okay, let's, oops, I don't know what I checked there. Let's throw this. No, do not upload that stuff. I just want to see this. Okay. So we have the round numbers, and I guess we can also check whether this is the smallest or not. So we have the chosen algorithm is vertical because 43 is smaller than 113, right? That does always make sense. So now I'm going to add a check. If my assumption is correct, meaning if it chooses the lower of the two. Encoded horizontal dot size is smaller than encoded vertical dot size. And this, right? So horizontal size being smaller and the chosen algorithm equals horizontal. That would be true if it's correct. And that also, is that also correct for the other one? So if the size is different, then the algorithm should be the other one, right? Yeah, I think that's correct. Okay, so we should have correct for, oh wait, no, my assumption is not correct. Okay, let's type it out. Bool correct false if round.algorithm equals correct equals encoded horse size is smaller than vertical size, right? If it's horizontal, then horizontal size should be smaller or equal. Well, what was the preference here? Where is that again? Like if they're both the same size, then they have to be, then it prefers one of the two. I did put that in a thing here, I think in a commit message. I guess I didn't. Where would I see that if I am encoding, right? Yeah, that's this one here. So if the vertical data length equals smaller, so this is the equals case, which is horizontal. Okay. Right. Yeah, that's correct. So horizontal is preferred if they're equal. Whereas this, if it's horizontal, no, if they are equal. Yeah, and then in the other case, correct equals vertical is smaller than horizontal. Okay, so now vertical because that's smaller, that's correct. Horizontal because horizontal, and horizontal is being preferred if they're both the same, which is true in this case. Horizontal is smaller than vertical. Okay, so do we have a false? Yeah, we do not have a false, so my assumption was indeed correct, that they prefer the sizes. Okay. Right, so now we have that data, that's good. I can use that in the video. All right, so that's done. Now back to this. What was it that I had to add? So we have importing, that's good. That X could be higher though. Let's okay. Just refresh this caching stuff. Okay. We had to dump a single level here. That's what I wanted to do as well. Should I change this one to an array first though? That would make more sense, I think. Yeah. Let's see. That would simply come down to doing the dump function. No, not the dump function, the JSON function. Yeah, so I did leave this out. And I left a round number in. Actually, I should just add this to an array, right? Actually, I'm going to re-enable this. Oh, and it's the raw data. Yeah. Let's separate this into a function because that's something else than to JSON, right? That's just raw data as base 64. So and this becomes a string. Right. So let's get this defined here. Yeah, we have this function now, and then we have to do 3 power-ups here. Just let the loop. Let's just do a little loop. And then power up hard frame accounts I, and then these become formats. Okay. So now we have our JSON back. Yeah, so let's dump that first. Not that we need that for something here, but why are we not? Oh yeah, we're not dumping it here. Okay, so we have our complete JSONs now. So we have the data, which is what? Which is the blocks, okay. And then we have the round number, we have low loss position, explicit position. Don't see the power-ups though. Oh, because there aren't any. Yeah, because we do check. So level 8 has, round 8 has power-ups. Which round is this? 11. Round 6, that's 7, and this is 8. Yeah, do we have power-ups here? Yeah, P0 and P, okay, that has to be +1, of course. Okay, so we have the power-ups and thing. Okay, now we need this, right, to generate our array of raw data. Okay, and then we will simply add that. So now we have an array, right? And we can dump that. And that should be a little bit smaller than what we have now, because we don't need a round number in here, it's just the index, right? And we don't need the D's and stuff. Yes, that's what we want. So instead of this, we have this. Okay, and then let's see where we reference this. Yeah, so this becomes an array. So this Eggerland 1 level data is now an array instead of an array of objects. Okay, let's start from the start here. Get Eggerland 1 level data, that's fine. Then we fetch it from the round number -1, which is also already correct, right? Because that becomes the index. And this goes to this function. Okay, instead of data D, we just go for data. And we need the round number though. Which is then a round number itself passed as a parameter, I guess, which becomes this. And then we have round number available here. Do we use this function? Nope, we do not use that elsewhere. We could actually move that. Yeah, if we're not using this elsewhere, why don't we just move this in there? Well, we might need it though later on. If we're loading the stuff from the database, we might need this because yeah, this function is specifically for one of the predefined levels, right? Not for custom levels, whereas this is universal. Okay, so let's see if that still works with our new data, right? That seems to be, but let's be sure that we have the correct file. So E1 levels is now an array of base 64 levels. So that's good. So now let's load again. Yeah, that seems to still work. All right. So I think that's a bit saved space here. If we compare this, yeah, look, that's quite a bit more. Right, so I'm gonna commit this first. Okay. And then now we can dump our little level, right? Because I want to, well, how do I want to do this? What I want to do is visualize each level, right? Just make a page with all the rounds on it. So we have to parse this, put it through this, right? Round number and bytes. And then, yeah, so this decodes. And then we have access to the blocks. And that we have to put on a screen. I guess we can just do that with the canvas though. We don't really need to initialize Pixie. Like it doesn't really make sense, right? To do that with Pixie, does it? Because we have to address multiple canvases as well. Like every round is going to get its own canvas. So we don't need to like initialize Pixie for every canvas here. We're going to do that on a different page. I guess we can keep working in folders. Yeah. Okay, so we have our index. Let's add the same thing here. I'm going to have to change this stuff. Well, I mean, I can do it though. I guess I should call it rounds here too. Title is I guess I do levels for Google, right? Some people type levels, some people type rounds. We don't need Pixie. We do need the Eggerland JS. Yeah, right. Because we need a round, and that does nothing with Pixie. Great. Because we're just gonna print out or render a little canvas ourselves. It's because it's a single paint thing, right? We have from hacking Eggerland and then levels. Okay. Okay. This looks weird though. This is because of my... Alright, this is because of my zoom thing. I need to look at that though, because that doesn't look good when it gets too small. I didn't look at it yet. Let's see what the levels thing does. Okay. We need to load... Well, I guess we just can call the A function in the window event listener, right? In the load event listener, right? And just add a container I don't really need to give that an ID, I guess, but sure. Actually, I don't want to render this in JavaScript because of Google, right? I just want to have the data in this as a table to start with, and then add the, like, paint the canvases with JavaScript. Right, so I need to export actually some HTML from this guy here, right? So I can just copy paste. Yeah, and I can even put the base64 thing next to it, so I don't need to load it. But I mean, I can load it though. That's not a big deal, because I need to load the sprite sheet as well. In any case, so I need to load stuff anyway. That's not a big deal. So let's see, what can we do. Let's first make a little mock-up here. Let's see if round 2 is good. No. Well, yeah, I guess we can do this kind of title. And then what do we need? Just a picture, I guess, right? Because we can't, well, the picture and the power-ups, but I don't think we need much more than that. So we have our canvas. Guess we're gonna have to give a width and a height. I think I'm going to add the... Wait, do I paint them on a canvas or do I use a sprite sheet? I mean, I guess I can split up the sprite sheet in different images as well, right? So, like, I don't even need all of these. Data round equals 1. Let's put that in there too. And then we're going to make a new JavaScript file. What is this? A round canvas, I guess. So we're visualizing the round. What are we going to call this? Round image, I guess. Then we have a constructor. with a canvas element. I guess we can pass the sprite sheet and stuff to here because we're gonna need that. Let's get our window load event in there. And then we are going to loop all the canvases, right? Elements by class name. Okay, so we have our canvases, which is containing 1 at the moment, sure. I guess we can do canvases for each. Does that work on an HTML collection? Oh, we can do array, okay, sure. Yes, that still works, okay. Okay, that's undefined, okay, sure. That's an HTML collection to array. Yeah, I'm not gonna do that. Let's just loop the old-fashioned way. Okay, that's sometimes way easier. Okay, so we have our canvas, and then we can, so let's include this in our little build script here. So then it's uglified and included. Okay, so we're along it here. Let's just instantiate the renderer. Okay, that works because we're definitely in this function, right? Yes. Okay. I guess we can just immediately render to the canvas in this function though. Is it data? What was it? Round? Data round. Is it get attribute, or can we just do data like this? No. I don't know if there's a specific function to get the data attributes. We could use get attribute with their full HTML name, but the standard simple array, don't string map. Get a data set. Okay, a data set. That's what I was looking for. Yes. Also, we need to initialize our loading of the level data, right? So let's see how we did that here in the construction mode. Right, so we are fetching the levels, and we are passing that, like, does JSON, do you have a JavaScript have a pass by reference thing, or did it always pass by reference? Okay, so we don't have to worry about that. I guess we just can immediately do this, right? So we have the correct level data. Yes, that's our base 64 thing. Do we need to decode this? I guess we do, right? Because we are giving bytes here to this function. So we have to do this. Okay. We have the bytes now, and then we have the round. And the round number is also queried from there, so that's fine. We don't need to put that differently. Right, we have our round, perfect, and we have our blocks. Now we just need to implement the rendering, right? So we have a canvas. Let's make that a fixed size. Well, it's 11 by 11, but we have to do 12 and do half on the top and bottom and half on the left and right for the brick wall. Right, let's load the sprite sheet though. How do we do that? I guess we can just put that as a hidden image in our body here. Source equals images Eggerland e1.png, I think it is. We don't need an alternative because that's a hidden thing anyway. Display none. Right, so can we access this sprite sheet? Now we do need to, yeah, so we have it, but we have to paint with it though. Get a reference to an image element, which we have. Draw the image on the canvas using draw image method. So the draw image method, I hope that has a source rect. Yeah, so image, source, x and y are with and height, and destination. Okay, that's what I need. So now I do need to know where the things are, where the sprites are located. That's this guy, but we don't need everything though. We just need yeah, a couple of these, right? So we're sourced them from this Well, not from this, but we'll just copy the information. That doesn't really matter. Let's paint on the canvas. Let's give it a nice background first. So we have the canvas element, right? What was the thing? I always forget this. Yeah, okay, get context, sure. Do we have an example here? Yeah, this one, what I was looking for. So now we have the context, and now we can draw or fill rect, I guess. Right, and then we do ctx fill rect. That's 0, 0, and then canvas.width. Not sure if that's going to work. And we're going to have to set a fill style. And I want the same background color as the construction mode, which is 222. Okay, so we have our little canvas here. Let's make it a bit bigger. Width equals, let's say 512. Let's see how that works. And then we have to do the same. We have to make it, well, that's going to be too big though. Yeah, that's too big. Let's give this half of this. Okay, let's start with that. Let's give this a static thing here where we have sprite locations, and then the sprite definitions we need as well, right? So I mean, we do have, I mean, I can export this. Right, how do I do it in enum JavaScript enum in class public static like I did in C++? Okay, can I just put that in the top level? Like if I put that in round, that becomes the first thing in the file, I think. Wait, I need these guys. And then we need to replace this with a colon. Well, no, let's do it this way. And at the end, we need a comma. That's why I wanted to do it that way. So, and also we don't need a cell in front. So now we have now we can just do sprite.wall, right? Do we have a cell underscore? No, we don't. But if we go here, no, let's comment this out. and find every cell thingy here. Like, can we now do sprite dot walkable space? Is this correct? I mean, it's gonna fail, of course, because there are other references that do not have the cell stuff in there. Sprite is not, oh, SR, okay. Yes, it looks like that works. I'm just going to replace all this stuff by sprite dot. Yeah, so now I've separated those out. That's good. That seems to work, right? Okay. Good. So we don't need this anymore. Yeah, these guys I can actually, well, I don't really need to, I think. These can go, these can peak, these can stay. Okay. Right, so we have sprites now. We can use the sprite thing in this function here. So we need a mapping from sprite.lolo, for example, to 0 here. That would be the first location, right? This is confused because it doesn't know about it, but it should do. Wait, why are you not? Oh, can it not do? Oh, crap. Why can't I use it as an index though? Into an array or an object? Why? Oh, do I need to put brackets next around it? Is that the way? Looks like. Didn't know that. Oops. Okay, so we need to loop now. Well, no, let's do the wall first. That's the easy one, right? Wall is 68. So I want to draw, well, 68 I have to convert though. I need to convert it to an XY, so I need to know sprites per row. So it's 16 and the sprite width is also 16. Okay, so location equals sprite locations of the sprite, and then we need to get x and y, right? So y equals the location over 16, because there's 16 wide, and we're gonna floor that. And then, 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 and then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 over 16, because there's 16 wide, and we're gonna floor that. And then the x is 16 is the location minus x times 16. Is that y times, I mean, is that correct? So y times 16 subtracts all the rows, and then what is left is the x position. We have padding as well, so I have to think of that. We have an x, y, but we have to multiply, so we return x times 16 pixels plus x times 1, right? Plus the padding, right? And then I times 16 plus, wait, but aren't they 8? But no, they're 16 plus y times 1 for the padding, right? Get sprite chords of sprite.lolo, and that should be the 0, 0, 16, 16, or 0, 0 for the xy coordinate, and then I should get a rect here. Right, 0, 0, but no, this should be get sprite rect. So 0, 0, well, let's do this. X times sprite size plus x times padding, right, and then sprite y equals the same, and then we can return sprite x, sprite y, sprite x plus sprite size. Wait, is that with an height or the end coordinates? Yeah, it's with an height. Okay, so that's just sprite size. Sprite size. Okay, that's the rectangle. Yeah, 0, 0, 16, 16. And for the wall, that would be a completely different number. Yeah, but looks correct enough. Well, 68 pixels in this file, 68. No, that's not correct. It's this one here, so that's not, wait, 68 looks like the index though. What is this? Yeah, 68 is the index, so why are we? Wait, 68. Oh, that's the 68th index, right? And we are going to convert that to an XY position. And there's 16 Y. So Y, so 68 over 16 is 4. 0, 1, 2, 3, 4, right? Because we're 0 based, right? Yeah, that should be 4. Floor is 4. So why is this not 4 to start with? Like this one should be 4, right? Over 16. So this is sprites horizontal. and then also sprites horizontally, right? So let's open this file. We're going to select 16 by 16, and it's this one. So this is at position 6868, so it is correct. Okay, that's coincidence then. Okay, you put me on the wrong track here. 6868 is correct. Okay, and that's still correct, right? I did change some stuff around, but that's fine. Yes. So we have the rectangle, the source rectangle. Now we just need to put it in the destination rectangle, right? So I'm going to do draw the border. Well, let's put this in a function though, to make things a bit more clean. Okay, so we have the wall source coordinates and we need the destination coordinates, right? So we're going to loop, let x equals, let's do it from 0 to 12. And we also have a scale factor, right? So no, this is would be sprite height or sprite size equals, or scale size equals canvas dot height over 12, right? Because we have 12 blocks and we're assuming it's rectangular, so whether it's width or height, that doesn't really matter. So we have a scale size. Okay, so we're going to, we need to context as well. We're going to draw an image. We can spread out the source rect, right? And then let's make the destination rect as a variable 2. And let's spread out 2. That should work. What's the thing here? Not fill rect, but draw image. Okay, so we need the image. Okay, that has to be the sprite sheet though. Where do we get this? This is this one. Let's put that in the class. Okay, and now we can reference that in our function here, this sprite sheet. And what's the following? And then source axis, source width, right? And then dx, dy. Okay, that's fine. That's just the other rectangle. We start from, so we're subtracting half at the end. We're starting from x times scale size minus 0.5. That's our x coordinate shifted half over to the left. We're doing the top row, right? And then y is minus 0.5, and then the scale size twice as the width and the height. Okay, so we're doing this 12 times. That should give us a border at the top. Yeah, but it's not offset. Oh, no, this is scale size over 2 times -1, right? And this half is also probably wrong. That would become minus scale size over 2, right? So const half size equals scale size over 2, and let's put that there. Why is that? Oh no, on the x-axis I don't need 2 offsets. It's just in the y position, right? It does seem though that we're picking up the padding thing. Did we not add padding here? Or is that like we're seeing, okay, that's not good. I'll have to look into that because I don't know how to, this might be with the DPS thing too. Let's see if it's the same in Chrome. Okay, that's super small, of course, but yeah, it has the same problem though by now I don't know if it's the padding or if it's just crappy at, well, I mean, this isn't a round number, I think. The scale size, if that's a fractional number, that might mess with things. Yeah, so let's pick a number that is a multiple of 16 or 8 at least, instead of 256, right? Well, that is a multiple of 16 though, right? Is it not? Well, yeah, 16 of course. So why does that not work? Oh, over 12. No. I need to do a multiple of, yeah. So I need 12 integral blocks of 16 high. Well, of not necessarily 16 high, but I need a multiple of 12, right? Yes. So 256 over 12 is not. Okay, so let's do 22 times 12. That's 264. Yeah, let's do that. Yeah, so now you don't get the, now you have perfect scaling, right? Or no, or at least no rounding errors. Okay. Good. So we have the left wall, now the bottom wall, I guess. Oh, we can do that at the same, in the same thing though. So if we go half size, so this is canvas dot height minus half size times 1. That's the bottom border. Why are we complaining? Oh, it's a const, of course. X is the same. Canvas height minus half size, not times -1. That's the bottom one, and then the left and right we can do in the same breath as well, right? So this is bottom and then left, which would be half size times -1. We start at 0. Well, no, x, well, that should be I then, I guess. I times scaled size. It's going to overlap, but that's fine. I hope that it matches. And then scaled size. Yeah, that might overlap there. Yes, and of course it does. So we do have to be careful and just do that 11 times, I guess. Right, because we don't want to overwrite the first half one and the first and the bottom half. So we start at half size -1, but we do start at, in the Y position, we start at half size plus. It looks like we're still overwriting, so we're doing half size plus I times scale size. Why would that be oh no, now it isn't. Okay, sure. Right, and that sort of matches, so that's fine. And now we do the right wall, which is simply canvas.width minus half size. And that should give us the right wall. Yes. Now we loop the items, right? Also with canvas and context, we draw the sprites. And we need the bytes for that as well. Also, we need to add some space for the power-ups though. I guess we just have to loop though. I'm going to assume it's 11 by 11, but that's the perfectly normal assumption. Actually, I can just do it with coordinates here. No, I can just do 11, it's fine. So we have an index into bytes. The sprite or the sprite equals bytes index, but then we need to get the sprite location. Equals this sprite locations for the sprite, and that has to be filled in though, but yeah, sure. And then we just draw it based on the XY position we are at currently. So we need to fetch the source rectangle for, no, that's just for sprite, right? Yeah, we don't need this location here because that's fetched in the, that's here, right. So we have the source rectangle, and then we just have to draw, well, let's get the test rectangle 2, and that would be again the same calculations here, scale size and half size, because we need to offset by half size, right? So x would be half size plus x time scale size. The y would be half size plus y times scale size, and the scale size is correct. And then we draw image from this spreadsheet, the source rect. That's going to crash because I don't have them all defined, and it's doing it in the wrong order. Why? Is my indexing incorrect then? X plus y times 11, that looks correct, right? We have 11 horizontally. I mean, I is picking the low and the wall though. That's correct too. Why would that not be correct? Let me look at the bytes here. Oh, are we including the header here? It looks like, but it's still not correct though. So 6, 1, 2, 3, 4, 5, 6. Yeah, that's low, right. What's up with the other ones though? Like the wall should work too. Wait, do I have wait, which one do we have here? We have blocks here though. Why are we not using blocks? We don't need bytes, we need blocks. Of course, it's wrong. We need blocks. So we have bytes here, but we have a round though. We need to specify this, not the bytes. That's better, but of course no more +6 now. Yeah, perfect. That's much better. And now we just need to add our sprites, of course. I'm going to get them from here and see what I need, right? I just need the names here, not the values. Right, so that's 68. Lolo is 0. Okay, so we have these guys. Walkable space. So let's see. That would be empty space, I think it's called here. Why is there no thing here for empty space? Oh, blank. Oh, jeez. 95. Medusa. Inactive. I think we should put, well, we can do active though. Well, no. Let's do as it's supposed to be. 61. Skull is 58. Snaky is a left front facing one. Snaky front left 23. Alma is the front facing one. Alma down. Front dark, I guess. Goal facing left is goal inactive left. Which one are we showing here? That's this one. This is active mouth closed. Yeah, this 44. Emerald Framer 69. Heart Framer 72. Goal facing right. That's goal mouth closed right is 48. Goal facing up, there's only one. That's 46. Then facing down is mouth closed down. Arrow up, down, right, left. Up, arrow up, down, right, left is 85 to 88. Up, down, right, left, 85. 85, 86, 87, and 88. Arrow left, right, and then we have respawn slot is 67. Water 78, and then the 4 directions are the following ones. Up, down, left, right is the same. Up, down, left, right. 79 to 82. 79, 80, 81, 82. Heart framer with bullets 73. Bridge vertical and horizontal is 83 and 84. And then the exit with the block on top, which is 75. And where is the exit with the block on top? Oh, 70. Okay, emerald framer over exit is 70. Okay, so now we have them all defined, and that puts us here. Okay. Now I'm going to add all the levels. don't think we need an ID. I mean, do I add these dynamically or not, right? That's the question. I mean, I guess I can. That would make most sense, I guess. We're logging something. Yeah, no bytes. This should also be blocks. Yeah, let's just instantiate that with code, because otherwise I have to do 115 of these, and that sucks. So we load in the level data, then we have the container. And let's do the first. Let's separate them in standard levels, extra levels, and bonus stages. So in H2, and we have a canvas. We're setting the attributes data around. Well, can I do data set here too? Class list, add around canvas. I don't know if we need a class though. No, we don't. Well, yeah, we're selecting by class there. I guess I can just store them here though. Then I don't need to load them up, and we don't need to do this. Right, I can just do this, right? And then I just have to add it to container append child h2 and canvas. We have the round, just the width and the height. And we don't have the class, we don't need an ID. That should be good, right? Okay, so these are all our rounds. Up until 100. I mean, they all look correct though. Yeah, we have directional water too. Yeah, that looks to be correct. And we have the things you don't really see online is where the bullets are and stuff. You usually see maps without the bullets and stuff. And the respawn positions are visible too. Okay, I don't really see any now. Did we add respawn position? Yeah, respawn slot is in there. That's weird. I thought it was more. It occurred more than this. Really, no levels with a respawn position now. Wait, is this correct? Yeah, that's correct. Why aren't there any with a respawn position though? A respawn slot? Oh yeah, here is one. Okay, yeah, that works. So we have our 100 rounds. Then we need, how do we call it here? The extra rounds or the special rounds and bonus stages. Okay. So let's add those two. Let's add a little function for that though. Okay. So we can reuse that for our special rounds. So we're starting at 101 and we're smaller than 105 or smaller or equal to special round. And then let's add 20. Oh yeah, let's add the 20 bonus stages. That's fine. So we're starting at 106 and we're smaller than 125 bonus stage, and that becomes I minus 105. Right, that should do the trick. So we have level, right, special around 100, special around 101, 2 and 3, 4 and 5, and then bonus stage 1. That's correct. Yeah. Okay. Yeah, and 11 is the same. This, of course, shows the exits, which are not present in the game, right? The exits on the bonus stages are not shown because it's a bonus stage. You just have to play against the time limit. But yeah, they are in there, of course. Okay, so these are all the mystery or the Eggerland levels. I do have to add the power-ups though. For which we need the font. Right, that also sucks, but that's fine. Let me add some text. So is this zoomed? I guess this is a... So this is at 100%. I might add the special key as well. The password for the specific levels, right? Right, those titles are the same size, that's good. Let me add a little bit text. Okay. I'm gonna have to add some width for the power-ups and use the font. Yeah, but that's something for next time, I think. Yeah. Let's commit this first. I might add some link to load this into the construction mode here directly by URL. So if you click here, then it loads it in the first level here. I might do that because if I'm going to put levels in a database, I'm going to have to visualize these as well in this way. And then I'm going to have to make them editable by clicking by adding a link here, so you can click it and it immediately puts this level into the editor, right? Instead of doing import and loading a level. Yeah, that's going to be the end goal. All right, but that's going to be it for now. Thanks for watching, and I'll see you next time.